This is the Earth, and in the Earth, you might find, if you dig in the land, you might find some gold. If you look in these clouds, you might find some droplets of water. If you look in the ocean, you might find some salt water. So, what's up with these things? Well, if we look at gold, well, this is actually a picture of gold atoms. This is taken by an electron tunneling microscope, and we're actually seeing the fuzzy outline of atoms here. And what I would like you to notice is the fact that they are all kind of the same here, along with the fact that they're all kind of neatly arranged in these rows and things like that, which I find kind of interesting. But they're all the same. It's all made up of one type of atom. That's a gold atom. So gold is made up of all gold atoms. Now, if we were to look more closely at these drops of water in the clouds, well, we would find that it's made up of a few different types of atoms, hydrogen atoms and oxygen atoms. And these guys are all kind of stuck together here. So that's a little bit different. It's not as pure a substance as gold. And then finally, if we look at the salt water under a microscope, what you would see is something like this, these little crystals kind of floating around in the water. So all of this dark area here is that H2O stuff, but all of this area, these guys are a different thing, and they're not really chemically stuck together. You could kind of take the salt and separate it from the water pretty easily. And so that's a whole different thing. And so what are we talking about here? Well, we are talking about elements, compounds, and mixtures. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. So take a look at the little mini periodic table you have on your notes. You have a partial periodic table, and I want you to understand that the full periodic table is really a list of the ingredients of the universe. It is all of the things, just like if we were to list the ingredients of, say, a cake or something like that in a recipe, and there's flour and there's eggs and there's milk. The periodic table is a list of the ingredients for the universe. It is the basic things, just like those things that I just listed are things that make up a cake, the basic individual things that you have to mix together to make up a cake. Well, all of these things on the periodic table are the basic things that we have to mix together to make things like, well, stars and planets and rocks and water and grass and trees and people and cell phones and anything else that you could possibly name in the universe is just these things kind of mixed together. But you probably recognize a lot of these things. So, for example, you probably recognize something like mercury. You probably recognize helium, and right below that, neon. And you might recognize sodium or potassium or calcium. These are all things that we tend to find in food, right? So that kind of makes sense. If they're the basic building blocks of all different things, well, they go into the stuff that we eat, and then that becomes part of us. So that's what we're made out of too. And so in the same way that things like flour and eggs, and stuff like that are the basic building blocks of foods like a cake. Um, these guys here are the most basic fundamental building blocks of all the stuff in the universe. Each one of these things is considered to be sort of a pure substance. So, those guys are what we call the elements. And they are just listed on the periodic table. I particularly like this periodic table. Take a nice close look at this. Lots and lots of interesting things here. Lots of interesting things here. So anyway, these are all the things that make up the stuff in the universe, and these are what we call elements. So elements are a pure substance that cannot be broken down into something simpler. You cannot really break an element down into other things. It's just made of that element. So for example, as I showed you before, gold is just made out of gold atoms. You can't really break it down into anything simpler, whereas water is made out of hydrogen atoms and oxygen atoms, and you could kind of break apart those into their basic parts like hydrogen and oxygen, which are elements on this periodic table. Just like you could say that cake is made out of flour and eggs, water is made out of hydrogen and oxygen. So water is not an element, it's made out of several elements. And so elements are things like hydrogen and oxygen and gold and iron and calcium and stuff like that. These are the building blocks of everything in the universe. Think of them like if you're playing with Legos and making stuff, this is one individual type of Lego. So maybe this guy right here, this first block here is, maybe that's one of the little rectangular blue Legos. And this is a rectangular red Lego, and this is a square blue Lego, and this is one of the flat Legos that has the little turny thingies on it, and this is one of the Legos that are the really little ones that only have 2 spots on them. So it's like different Legos, and so you can put those different Legos together, and if you wanted to, you could choose all one type of Lego to make, say, a wall or something like that. You could choose all of your blue rectangular Legos and make a wall out of it. Well, that's kind of like what gold is, or silver, for example. Gold and silver are elements on this periodic table, and it's kind of like if you have a bar of gold, it's like building a wall with all one type of Lego. You don't have any red Legos in there, you don't have any square Legos in there, you just have blue rectangular Legos. That's kind of like what a bar of gold is. It's all made up of one type of element, one type of atom. So something like this, for example, this nail here, this iron nail, is made out of all iron atoms. There are no other types of atoms in there. This copper wire is all copper atoms. It is made of nothing but copper atoms. And this little nugget of gold right here is all made of gold atoms, just like I showed you in that picture earlier. So, one particle of an element, one piece of an element, kind of like one Lego, is what we call an atom. That is a single particle. That is the smallest amount of that element that we could have. You could say, just like the smallest number of Lego blocks of that type, the smallest number of blue rectangular Lego blocks would be one rectangular Lego block, and you could take that wall apart and just have one individual blue rectangular Lego block. Well, this is kind of like that one blue rectangular Lego block. This is one individual atom. Okay, so compounds. Compounds are kind of like if you want to take several different types of Lego blocks and kind of start messing around with those. So you don't want just your blue rectangular Lego block, but maybe you want a red rectangular Lego block, and you want a square Lego block, and you want the ones that just have 2 little spots, and you want to build a wall of all of those different shape and size and color Lego blocks. Well, this is kind of like a compound. This is made of 2 or more elements that are chemically joined, or what we would call bonded together. This is kind of like sticking together your Legos. And one particle of a compound is called a molecule. So for example, it's kind of like, you might be wondering why I got this Mickey Mouse down here. Well, the ears are like hydrogen atoms, and the face is like an oxygen atom. So that would be one molecule of water. two hydrogen atoms and one oxygen atom. So the element hydrogen, two of those, and the element oxygen, one of those, they're all stuck together or chemically bonded together, like sticking your Legos together. That would be one molecule of water, and when we have a whole bucket of those molecules, we would call that the compound water. So elements are all made up of one type of atom. Compounds are made up of several different types of atoms stuck together in what we call molecules. And the next thing we have is what are called mixtures. So a mixture, as you saw from that little animation there, is kind of like a pizza. A mixture is a combination of two or more substances, but they're not chemically combined together. So think about this. Can you reach into a glass of water and just pull out the oxygen? No, you can't do that, right? I've never been able to do that anyway, but you could reach into this pizza and just pull off a piece of pepperoni, or you could just pull off some cheese, or you could kind of get that cheese out of the way and get some sauce underneath. They are not chemically bonded together, they're just kind of mixed together, right? So I think you guys know what a mixture is. All right, I want you to look at this and I want you to tell me what it means. Well, you can tell yourself what it means because I won't be able to hear you because you're at home watching this video right now. Anyway, there's two different types of mixtures that we can have, and I want you to take a look at this. Look at how these guys are arranged on the left here, and look at how these guys are arranged on the right. What do you notice? Good. You notice that these guys aren't really mixed up very well. These are all kind of separate over here in their own little area, and these guys are separate here in their own area. These guys are mixed up much better. They're all kind of together. So a homogeneous or homogeneous, however you want to pronounce it, mixture is a mixture that all the stuff is really well mixed together. A heterogeneous mixture is one in which everything is kind of separate from each other, okay? So a couple examples. Homogeneous, heterogeneous. Homogeneous, Kool-Aid, all kind of mixed together. Heterogeneous is kind of separated. The pepperonis are in their own little spot. The cheese is kind of in a separate spot. The sauce is in its own spot. The crust is in its own spot. They're not really all mixed together evenly the way Kool-Aid is. By the way, that looks like a really good lunch right there. So here's another one. This is a homogeneous mixture here. This is a heterogeneous mixture because all of these guys are kind of separate in their own little spot. We can imagine that we could take a spoon and kind of jiggle these guys around and mix them up a little bit more and make it more homogeneous. Okay, now one more thing before the review here. I would like you to turn your notes paper over and try to complete as much of that concept map as you can using your notes. I'm going to be checking that in class. If you have a couple missing things because you weren't sure, that's okay. We'll go over it in class. But you should be able to complete at least almost all of it, if not all of it. All right, and there you have it. That one was pretty painless, pretty quick one. We have elements, which are a pure substance, like the ingredients of a cake. These are the ingredients of the universe, and they are something that you cannot break down into something simpler. Gold is made up of just gold atoms. That's it. They are the building blocks of everything in the entire universe. Compounds then are made up of two or more different elements. So you have a lot of elements that are stuck together or chemically bonded together. And one particle of this is called a molecule. And a mixture is a combination of two or more substances that are not chemically combined together, like a pizza. You can pick the pepperonis off. We have homogeneous mixtures, which are evenly mixed, and heterogeneous mixtures, which are not evenly mixed. And we'll talk more about this in class, and I will see you then.